Okay, we're looking at some functions up here as well as Venn diagrams. What we're looking at here is we're going to just try and translate this into letters that stand for the functions that we have up there. P is going to stand for the entire statement that Sarah is a political science major. And Q is going to stand for the statement that Jane is a quantum physics major. And now our job is to write in symbols, Sarah is not a political science major. Another way to say that is, it is false that Sarah is a political science major. So here we represent, if Sarah was a political science major, that would be done. But it is false that Sarah is a political science major, so we want to negate that, and that's the end of that. We want to say Sarah is not a political science major, or it is false that Sarah is a political science major. We would go with negation of P, and that's it. We now move to the Venn diagrams, which represent numbers. Here they go 1, 2, 3, 4, 5, 6, 7, 8, and 9. They're scattered throughout different spots, right? Solely in A, both A and B, solely in B, not in any of them except for the universe. And we draw from our universe, and let's see, what do we have when we have A and B? B needs both, and this needs at least one. And I'm just writing it here if we can zoom in on it for a little bit. And the complement is going to mean opposite. So if we can get a peek at what I've just written here, those will be helpful for you. Actually, I can slide them in a little bit, so we can refer to them as we need to. But this is saying A and B. That means that we want to be in both A and B at the same time. So if we find anything that's in the circle of A as well as in the circle of B, that will qualify for our set, which gets a squiggle in front and a squiggle behind. And what's in A and B? Well, 1 is in A and in B, so I'm going to put 1 in. I'm walking my way across the universe by going numerically in order. 2 is only B, 3 is only B, 4 is only B. Those are no good. 5 is only A, 6 is only A, also no good. 7's got nothing going for it as far as A or B go. 8 is in both. That's what we're looking for. So 8 joins 1 in this set. 9 is out here and in none. So the items that are in both A and B are 1 and 8. A or B, at least one of them, you have to be in at least one of the circles. So if you lie in any of the circles, or whatever we want to call this teardrop, anyway, if you lie in either of those fences, in one way or another, as long as you're in at least one of them, you're going to come in. So we go across and we get 1 is in A as well as B. 2 is in B only. 3 is in B, and these are all good by being in something. 4 is in B. 5 and 6 are in A. That's good enough. 7 is not in anything. We're not putting 7. 8 is in both, so A puts it in, and B kind of doubles down on it, and then 9 is not in either. So that finishes that out. And now the complement of A, right? This can look like a small 1 or apostrophe, but it's saying the complement of A, it means everything but A. So we go through the universe, and if it's not in A, it's coming into this set that we're creating. And so 1 is in A, so we don't get it. 2, 3, and 4 are not in A, so they come our way. 2, 3, and 4, all not in the circle of A. 5 is in A, 6 is in A, so we don't get them. 7 we do. 8 is in both, so that's no good. And 9 is not in there, so we close it out with that. And we're done with these problems dealing with our values that are in particular positions in our Venn diagram. So that's what we have for you right here. We're going to continue in just a minute, but I have to make some space. So here we are, we're looking at sets. We're going to go across the universe and see what gets to go into the set we're looking for, commas separating the ordered elements in our set and then closing it up in a set of braces. So if we want, what this one is asking us for is the complement of A, as some people would think of it as the negation, but it's a complement when you look in a set. What's in the universe that's not in A? And so when I look at it, I find that 2, 4, and 5 all fall below 8, and so they're not in A. 8, 11, and 13 are 8, 11, and 13 are in A. They're not welcome in the set we're looking for right now, this complement of A, the stuff that's not in A. Now you pick it up at 18 and 20, and that's it. We've reached the end of the universe, and that's what we've got. 2, 4, 5, 18, and 20 are in our universe, but are not in A. We're now going to go to number 6 using this different universe with sets A, B, and C. And we're going to make sure that when we do this work, we work with A and C. Even though B is available, this first one and the second one do not involve set B. So we shouldn't be attracted to look at what's in there. U is going to be the numbers between the integers between 21 and 30 inclusive. A, when we get to it, is going to be from 24 to 27 inclusive. B is the odd numbers from 21 to 29 inclusive, and C needs to be described. It's 22, 24, 25, 29, and 30. I don't know the pattern to that, so I had to give you a full list of what they were. Here we go. We want something that is A or C. Or is what the U is. It's kind of a union. It's got to be in at least one of the sets. If it's in one of the sets, it's going in. So I'm going to look at A as well as C to see what I can bring in. Going across the union, I begin with 21. Not in A, not in C, doesn't come in for us. 22. Not in A. In fact, we won't get to A till we reach 24, but C offers me 22. 23, of course, is not in A. 23 is a gap in C. 23 does not come in. 24, I see it in A. That's all I need. I mean, 24, 25, they are both in C, but when I look at what A is offering, 24, 25, 26, and 27, those are all good to come right in up to 27. I don't need to look at A anymore. I got myself up to 27. Now I'm considering 28, which I know not to look at A anymore. I can, but it won't come up with anything. And I look here, there's no 28. There's a gap there, so I don't take 28. I look at 29. That's there, as is 30. And I'm going to close this out with 29 and 30. And we've got 22, 24, 25, 26, 27, 29, and 30 in A union C, A or C. I wrote that again, that's weird. This is supposed to be a different one. This is supposed to be A and C. For this one, I need it to be in both set A and set C. So if it's not in set A, it's over. I don't even have to worry about C because I need A to get it to allow it to go to the next round and see if it also has C, because you can't have both if you don't have the first. So I'm looking across my universe, and I don't hit anything in A until I reach 24. So I'm going to begin my search at 24. 24 is in A, 24 is in C, so I get that. Universe now says let's go 25, which A has, but 25 is also in C, so that gets to be in 25, is in my A and C. Universe asks about 26, which A has, but C does not. Gap right there. Universe has 27, A has 27, but C does not. And then A stops having anything at 27, so 28, 29, and 30 are immediately kicked out by not having A, and that's made up of nothing but 24 and 25. So the only things in A that are also in C are 24 and 25. The first two in A find their ways into C. Otherwise, C's items are too low or too high. And now we've got work ahead of us. This is going to follow the concepts of take any complement as soon as you can, just like we did with the negation. When you have a single value that you can take the negation of, which is now a set of values, we can negate it in the truth tables. We can take the complement as soon as we got a single set to do that with, and complete from the inside parentheses outward. So we're looking to these parentheses, but the first thing we got to do is take this complement of B. So when we get to that, it's going to be B's complement. We might as well get that going now. Let's figure out what B's complement is. We're going to need that later. So we go across the universe, and we look for stuff that's not in B. 21 is, 22 is not in B. So we're going to go ahead and get 22, not in B. 23 is in B, 24 is not in B. 25 is in B, so we don't get it. 26. B has 27. B does not have 28, so its complement will have 28. B has 29, but its complement will get 30. So we've got that over here. And when we need to do that OR, we're going to bring this guy up and do an OR with him. Okay, now I got to work on this. First thing I would do is I would take A complement and see what A's complement is. And so I'm going to what A has, 24, 5, 6, and 7. I want everything but 24, 5, 6, and 7. A's complement, I'm getting this, because I can take that complement right now. I can't do that, and I certainly can't do that. Complement of A. So in the union, we've got 21, 2, and 3. And there may be more. A brings me up to 24, 5, 6, and 7 that I cannot put in its complement. I go 28, 29, 30. And now I need to do more work with that. I need to take A's complement and I need to do A's complement or be in C. So I'm going to set that up. Therefore, I'm taking these guys and anything that C can add to it from the universe. The universe goes from 21 to 30. So this already has me covered 21 to 23. I'm going to start looking at C. Right now, live C. See if 24 is in C. 24 is in C, so I'll bring it into what I'm working on right now. I've got all these guys, 21, 2, 23. 24 comes in for its presence in C. Now I'm going to go 25, 6, and 7. I need to look at C. 25 is there. This would say, see if somebody else can help me out with 26. I look at C, it cannot. 27, it cannot. Then this guy picks me up for 29. Oh, sorry, it picks me up for 28, 29, and 30. That is A's complement or C. I now need the complement of that. So I'm going to write this and take the complement of that, which means I look at the entire universe and I say, what's missing from that, right? This is some of the universe. Whatever else is in the universe now, thanks to taking the complement, I'm going to do that. So I look at my universe and I see it goes 21 to 30. 21, 2, 3, 4, 5, and 6. Also 21, 2, 3, 4, and 5 are there. 26 is coming up next, and it is not in there. 27 is not in there. 28, 29, and 30 are there. So now what I have is this. I'm going to take the two things that I have, and I'm going to do the union of what they make. We have from the first parentheses having been complemented, nothing but 26 and 27. Okay, and now we are going to do that an OR with a set that contains these 22, 24, 26, 28, and 30. And now we're doing the work of what that has. It's got to occur at least once. This guy begins at 22, and I'm staying in order. So I look at what each one has to offer. That guy says take 22. This guy says, how about 24? This guy offers 26, so does he. We'll take 26 from somebody. It doesn't matter who. This guy offers 27, and we take it. That guy offers 28. And that guy, he's got none more to offer. This guy gives us 30, and we have our set. Retracing the process in that one, I found this, and I put it aside. Just the complement of B. I determined what that was, and then it needed to wait until what it was getting ORed with got determined. Began with finding the complement of A. Then I did that, or could have any of the elements of C. Took what that made, and I got the complement of that out of our universe. That got me to this, which put this on the left side, or in the middle, and that on the right, and anything occurring at least once wound up in our solution set. And then we're done with our set theory.